So in this class, let us define gradient. Okay. So first let us define a gradient here. So let us define a gradient. Right? Yeah. So here the gradient is given by denoted by grad, and that is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Right? So for any scalar function phi, so phi is a function of x, y, z, we can calculate the gradient of phi. So what is that? The gradient of phi is denoted by this, or simply we can call this as grad phi, right? That is given by, so I into dou phi by dou x plus j into dou phi by dou y plus k into dou phi by dou z. Right? Okay, this is the gradient. Now, for a vector function, so vector function is given by f1 into I plus f2 into j plus f3 into k. Right? For a vector function, we can calculate the dot product of gradient with the vector function, and we can also calculate the cross product of the gradient with the vector function. So if I calculate the dot product with the vector function, so that is known as divergence of f. Okay, so that is given by here we know what is the gradient, we know what is the function f. So if I do the dot product, we have to multiply the coefficient of I. What is that? It is dou f1 by dou x plus multiply the coefficient of j, dou f2 by dou y, and then multiply the coefficient of k. So that is dou f3 by dou z. Right? So we can say that if the divergence of a vector function, if it equal to 0, we can say that the vector f, the vector function f is solenoidal. Solenoidal in the sense it has no divergence. Okay, you can simply say that f has no divergence. Right? Okay, fine. So later, if I calculate the cross product, what happens? Okay, so let me take a grad and let me calculate the cross product of that with the vector function, and that is known as curl. That is known as curl of f, which is related to the rotation of the given vector function. So that is given by determinant of I, j, k. Here it is dou by dou x, dou by dou y, and dou by dou z, and here it is f1, f2, and f3. Right? So this is what? This is the curl of f. We can simplify this. So this is nothing but what? Which is I into, it is let us delete the corresponding row and column, and let me consider determinant of this. What is that? It is dou f3 by dou y minus dou f2 by dou z minus j into, so plus minus j into, delete the corresponding column and row and consider determinant of the remaining things. It is dou f3 by dou x minus dou f1 by dou z. Right? Okay, later plus k into, again delete the corresponding row and column, so consider determinant of this, which is dou f2 by dou x minus dou f1 by dou y. Right? This is the curl. And if the curl of a vector, if the curl of the vector f, if it is equal to 0, we can say that the vector function f is irrotational. Right? Sometimes we can also say that it is a conservative field. If we treat f as a field, we can say that it is conservative field. Right? Okay. So these are the basic things we need to come across. Now let us solve the first problem. Okay. So let us solve the first problem. So the force in an electrostatic field is given by, so F equals to this. So F is given, what is F? It is 4x square plus 9y square plus z square, which is a function of xyz, which is a scalar function. We need to find the gradient of divergence of F. First let us calculate the gradient of F. To calculate the gradient of F, first we need to calculate the partial derivatives of F with respect to x, y and z. So let us calculate the partial differentiation with respect to x. So here it is dou by dou x of what? Which is 4x square plus 9y square plus z square. Right? So here first we need to mark the constant terms, because since we are doing partial differentiation with respect to x. So other than x all are constant. So 4 is constant, and this 9y square is constant, and this z square is also constant. So now let us do the differentiation. So what happens here? It is equal to, so 4 is constant, the differentiation of x square is 2x plus the differentiation of constant 9y square is 0, and the differentiation of z square is also 0. So it is what? It is 8x. Right? Okay. Let us calculate the partial differentiation with respect to y. Right? Dou f by dou y. So that is equal to what? So it is dou by dou y of, again it is 4x square plus 9y square plus z square. So here which one is constant here? So since we are differentiating partially with respect to y, so 4 is constant, x square is constant, and 9 is constant, and z square is, other than y all are constant here. Okay, so now let us do the differentiation. So this is equal to, here 4x square is constant, the differentiation of constant is 0, plus 9 is constant, the differentiation of y square is 2y, and plus z square is constant, the differentiation of that is 0, so which is nothing but what? Which is 18y. Right? Okay, so let us calculate the partial differentiation with respect to z. So that is equal to what? It is dou by dou z of 4x square plus 9y square plus z square. Right? So now we have to calculate the partial differentiation. So here other than z all are constant. So you have to mark the constant terms like this. Okay? Yeah. The partial differentiation of constant term of 4x square is 0, plus the partial differentiation of 9y square constant, which is 0, and the partial differentiation of z square is 2z, so which is equal to 2z. Right? So now we can calculate the divergence of f. Okay, sorry, the gradient of f. So the gradient of f, which is given by, so here f is not a vector here, it's a scalar function, right? The gradient of f is equal to, so I into, so dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. Now let us substitute these values here, which is I into, so dou f by dou x is 8x plus j into dou f by dou y is 18y plus k into dou f by dou z is 2z. Right? And we need to calculate the divergence of this. Okay, so let us calculate the divergence of this. Okay, so the divergence, let me call this as the capital F, the gradient of F as capital F. The divergence of the gradient of F, the gradient of F is capital F here. It's a vector, right? It's nothing but what? It is the dot product of grad and F. So this is nothing but what? If F equals to here F1 into I plus F2 into J plus F3 into K, the dot product of grad and F is given by dou x of coefficient of I. What is that? It is 8x plus dou y of the second component coefficient of J plus dou z of the coefficient of K, right? So here the partial differentiation of 8x is 8 plus the partial differentiation of 18y, which is 18, and the partial differentiation of 2z, which is 2. So it is nothing but 10, it is 28. Okay, so we got a number. So divergence of the gradient of F is 28. Okay, at 5 minus 1 minus 11 also it is 28 because it is independent of x, y, z.